As SQL Server has evolved to be able to work with complex data in an ever-widening variety of scenarios, it's added support for more complex data types. One of the more intriguing features is the spatial data types. This is data that relates to points and shapes on a two-dimensional grid, such as you might use to store locations on the surface of the Earth or locations within a large warehouse. With spatial data, you can store location-based data in a database and display it in a client application that uses tools like Google Earth, Microsoft Bing Maps, or any kind of geographic information systems or GIS application. With support for this kind of data, SQL Server supports the growing use of location-aware applications and other location-based uses. SQL Server provides two data types to support spatial data: geometry and geography. Microsoft implemented these data types as Systems SQL CLR types. They're written in .NET code and use the .NET Framework and Common Language Runtime, or CLR. So these types do more than just provide a place to store data. They're rich classes with properties and methods that let you perform sophisticated manipulations of spatial data. Now, spatial data is a complex feature that's built on millennia of human map-making experience with complex algorithms based on a variety of standards that support GIS applications and data. SQL Server includes two spatial data types, geometry and geography, that encapsulate the database's support for spatial data. Each data type includes pretty much the same point, line, shape, and collection objects, as well as a rich set of methods and properties for working with these shapes. So this figure shows the hierarchy of available objects. The way this works is that you define a field or variable as either the geometry or geography data type. So that's the field type. Then you assign that field or variable data that describes the point, line, shape, or collection that you want to store. So it's the type of data that you store within each of those data types that defines the particular shape it is. So in this figure, the yellow objects are abstract objects, while the blue objects are concrete objects that you can store in the spatial data type. The only difference between geometry and geography object hierarchies is that in geography, there's a full globe object, and that represents the complete surface of the Earth. And you can see that in the lower center part of the figure. This is in a lighter color and dashed line because it's not part of the geometry object hierarchy. Now, the shapes defined by the various spatial objects are vector objects, which are collections of points, lines, curves, polygons, and compound curves. You're likely to use a few of the spatial objects most often to store and manipulate within SQL Server. One's a point. You can see that in the upper left part of the figure. This is identified by a pair of coordinates as an exact location as x and y coordinates, but can also include z, which is elevation, and m, which is measure. SQL Server doesn't directly use the z and m coordinates, but lets you store the data so that client applications can use them. Another common one that you're likely to use is line string on the left side of the diagram. This is a path along a sequence of points. It's a one-dimensional shape. It has length but no area, even if multiple connected line strings look like a closed shape. The line string is simple if it doesn't cross itself, or called a ring if the starting point is the same as the ending point. Another common one is a circular string. This is similar to line string, but defines a curve as a portion of a circle instead of as a straight line. And then a polygon is a closed two-dimensional shape, which is a ring. A polygon has both a length property, which is the outside length of the line that defines its shape, and an area. It can have holes in its interior, the shapes of which are defined by other smaller polygons. And then the area of a hole is excluded from the area of the outer polygon. You can also create collections of these basic shapes, including a multi-point, multi-line string, and multi-polygon, each of which can contain only the specified shapes. If you need a collection of any type of shape, including the multi-shapes, you can use a geom collection. So all of this makes it very easy to work with groups of shapes as a single unit so you can describe all kinds of complex shapes within the data within your database. All right, so as you can see, there's some rich functionality available for working with spatial data. And the nice thing here is that Entity Framework supports it all. Okay, so Entity Framework supports both the geometry and geography data types for location-based data. All right, so the types in SQL Server are .NET types, and so they have rich interfaces. They can have methods, properties, behaviors, and so forth. And they're included within the system.data.entity.spatial namespace. And they require the use of .NET 4.5 and later. One of the places where AdventureWorks 2012 implements spatial data is in the person.address table. So I'll go ahead and expand that. Look at the columns. And you can see here that the spatial location is geography. Now the reason it's geography is because these are locations on the face of the planet Earth. If this was a location within a warehouse, maybe even a location within a downtown grid within a city, there might be a geometry where it's more geometrical type shapes. But geography, that data type, understands the curved nature of the planet. Okay, so that's the data type there of that. Let's take a look at the data. I'm going to go ahead and select the top 1,000 rows. And here you can see that spatial location. It's stored as binary data. But there's this nifty tab here that was included in a version or two ago in SQL Server called Spatial Results. And what this is going to do is it's going to display all of the points within this data set for any of the fields that have spatial data. So in this case, spatial location is the only field, but I could select different fields if multiple fields had spatial data. And then I can also select a projection. I'm going to just accept the default there. But if you really kind of squint your eyes and look at this, you can see that this is roughly the outline of the United States, maybe a few points up here in Canada, and then this is some points in Europe, and then you can also see a few points down here in Australia and New Zealand. Okay, so now this is a very simple way to display this data. If it's different shapes, it'd be a little bit more useful to display a rectangle or more complex shapes. But this gives you a feel for the data. And certainly within a client application, you could plot this data on a Microsoft Bing map or a Google map even, and display and see the outlines of the countries and so forth. Okay, so that's the spatial data that is contained in the address table. Now, one thing about this is that the weird thing about this table is that Microsoft in sample data can't use real information. So all of these addresses are made up. So if you try to plot this address in Bothell, wherever that is, I forget what state 79 is, it's not going to correspond to this spatial location, almost certainly. Actually, I guess that's in Washington. So there's a little bit of weirdness in this table. So I'm just going to work with this spatial location data. But anyway, that's not going to be a problem in a real application. Presumably your street addresses are going to correspond to any latitude and longitude settings that you have there. Okay, let's go back over to the model. So this is the AdventureWorks 2012 model that I created from that database. Okay, so this is the spatial location. That's that field that has the spatial data within the database I just showed you. If we look at properties for this, you can see that it's the geography type. Okay, so if I drop down this list, you can see that that's a geography type. Can also have a geography collection, line string, multi-line string. So there's a lot of different options here for both of those data types. So it'll look at the data inside that spatial data and pick the correct option. And if you know you're only going to include specific, say, geography points, then you could select that option. Okay. But in this case, it's just using geography, and that works fine for the application here. Okay, so because Entity Framework fully supports spatial data, I don't need to make any changes to the model. The support is all there, we're done. All we really need to do is start adding code to use this data. So I'm going to come over to my home controller, and I'm going to add a new action method. Now what this method is going to do is it's going to use the location of Fairbanks, Alaska. It's my hometown, it's the location I'm at right now, and it finds the AdventureWorks person address that is closest to Fairbanks. And that's going to turn out to be in Newton, which is a suburb of Vancouver, British Columbia. AdventureWorks doesn't include any address information within Alaska. Okay, so the first thing I need to do is I'm going to be using these data types, these spatial data types, so I want to add a using statement. So I'm going to use system.data.entity.spatial. Now, one word of warning about this. In earlier versions of Entity Framework, most notably Entity Framework 5, this namespace was system.data.spatial. But somewhere along the line, and I think it might have been with Entity Framework 6 or 6.0, they added this entity. So they kind of got a little bit more granular with where the objects are located. So just be aware, you may see some sample code out on the internet that has a different namespace there. Okay, so I am going to create a new public. It's going to return an action result. And I'm going to call this spatial data. Hopefully you're more creative in your action methods that you name in your applications. So the first thing I'm going to do is define a location. And to do that, I'm going to use DB geography. So that's the data type that I need to use within my application. That's how .NET is implementing those spatial data types. And I'm going to use from text. So you can see there's various ways of getting this information because I'm going to type in text. And I'm going to identify a point. So that's one of the geometry and geography shapes. In this case, I'm using geography. And I'm going to specify the latitude and longitude, actually the longitude and latitude of downtown Fairbanks, Alaska. That's 147.716.389. And the latitude is 64.838840. Go into parentheses and complete that, and hopefully that's correct. So point, open parentheses, 147.716.389, 64.838840. And so you can go to Google Maps and verify that. In fact, I think that's probably where I got that latitude and longitude from. All right, so now what I'm going to do is define a closest variable. And for that, I'm going to use the DB addresses. So that's a collection that was defined as part of that entity data model. And I want to include the state province field with the initial reading. So I'll include that. Okay. That's just a kind of a quick and easy way to make sure that that data is loaded along with the underlying data. And then I'm going to order that by going address into a.spatial location. So that's that spatial data type. So it's a property of that of the address object. And I'm going to use the distance method. So this is a method that's implemented as part of that type. So this is part of the benefit of this being a .NET type. So I'm actually using .NET types that are included within that namespace. And then that's going to pass that as a query to SQL Server in order to return the closest location to Fairbanks. So I'm going to use that location object, that variable that I defined. And then I need 3 closing parentheses. Okay? And then I'm going to return the first or the default. So stepping back, what the closest is going to contain within it when this code executes is it's going to return or going to contain the address, the single address object that includes state and province data, because that's related data. It's ordering by the location. It's going to return the first in that set of data. It's ordered by the location, so it's going to be ordered by the closest address to Fairbanks, the next closest, so that the last record is going to be the furthest location from Fairbanks, Alaska. And then I'm using first or default to return the first item in that collection, so that's going to be the closest one. Or if there's none that match, I don't have a where clause, and there's data in the table, so I'm going to get data. But if this query, if I included a where clause, or if there's no data in the table, it's going to return a null. Okay, and so I can check for null if I want to. So then what I need to do is just return the view, so again, using that view method to return a view result, and passing in that closest object. So that's going to be an address object. And I'll save my work. Okay, so that's all I need to do. It's built in. I can use link expressions, link queries in order to grab the spatial data. And I can use methods on that data type, and there's a whole bunch of other ones, in order to perform various functions. In this case, looking at the difference between locations. Okay. So now, the next thing I need to do is create the view for this action method. So I will right-click within the action method, add a view. I'm going to accept the default name. In this case, I'm displaying the information for a single record, so I'll select details. It's going to be strongly typed, and I'm going to use this address object because that's the type of object being returned from that link expression. Okay, I've previously used this dialog box within this application, so it selected the default AW entities, the only context object that I have within this project. And I'll accept the other defaults and create that view. All right, so it created entries to display all of the data within that table. So I'm going to clean this up just a little bit. I'm going to leave the title as spatial data, but I want to identify to the user what this data is. So I'm going to use a H5 header and say closest AdventureWorks address to Fairbanks, Alaska. Okay, and then so this is going to, I have a header of address, and I have horizontal, and I want to go ahead and display the address line 2, and actually I'm going to clean this up just a little bit, just to kind of show you a technique that you can use. I'll do Control-KD to clean up the formatting a little bit, but I only would want to display address line 2 if it's non-null. So I can use an @if, use that model object, and address line 2. And if it's not equal to null, I want to display this section of data. So I can have an opening bracket, and then I'll bracket this address line. Oh, I put that opening part in the wrong place. Fix that. Because I want the label to be commented out as well. And Razor tries to reformat things a little bit for me. Okay, so just a little bit of nicety for the user interface. All right, I want to display the city, the postal code, and the spatial location. I don't really need the row GUID. It's not useful to user. I'll include the modified date to see what the date was there. And I'll put the state province. This is coming from a related table, which is why I needed to use that include statement in the code. So I'm going to put this more in the logical location, which is right before postal code. Okay, so it'll say city, state province, postal code, spatial location, and typically in a real application I wouldn't want to display this, but it actually is kind of interesting to include it. So I'll include that and include the modified date. Okay, I don't need these links at the bottom, so I'll get rid of those. And then the last thing I need to do is add a link to my index view. So I'll come back over here and I'll use that HTML action link again. And so the text I want to display is spatial data proximity. And in this case, I want to execute the spatial data action method. Okay. All right, I will save all my work and run the application. And if I did everything correctly, we should find out who the lucky person is who's closest to Fairbanks, Alaska. Oh, didn't put in line break. I'll fix that. Didn't. Okay. It's been thrown by target of an invocation. That's not helpful. It's on this. What did I do wrong? Okay, view detail. Exception has been thrown. That's not a useful exception. Enter exception. The number is expected at position 17 of the input. Okay, so I did something, formatted something wrong here. Okay, go away. Now it's on that line. Okay, so I have it in quotes. I have parentheses, 147. Oh, yeah, the format for points doesn't, oops, yes, stop. I want to edit. Doesn't include a comma there. It's just a space to delimit the values of a point. Okay, good catch, Visual Studio. Actually, it's probably SQL Server that caught that. Okay, try this again. And another exception. Okay. Occurred in, go away. Enter exception for details. Type geography is not comparable. It cannot be used in the order by clause. Well, yes it can. I think so. DB addresses include state province. That's good. Order by. A goes to A dot spatial location dot not difference, distance. Distance, location, first or default. Okay. Third time's the charm, and as long as I'm thinking about it, let's put in a break here and run the application again. Okay, we have that nice line break, run the application, and we have our desired result. Phew. Okay, so this is the closest AdventureWorks address to Fairbanks, Alaska, 5468 Boxwood Drive, Newton, British Columbia, in the postal code. And then here's a text representation of that binary, or at least hex data, within the database. So you can see the coordinate system ID. There's a whole bunch of different coordinate systems that you can use with GIS data. The most important thing here is the latitude and the longitude. And so that's the data that SQL Server is using to calculate the difference between the locations of those address points. And as you saw, I can use that distance method within a link expression in order to perform various actions like this. And again, there's a whole bunch of different things that you can do with spatial data. It's just one very simple kind of example. And as you saw, there really wasn't much I had to do to implement this. I have to understand that there's features of the spatial data types that I can use, but I didn't need to modify my model. I didn't need to do anything really fancy with code. It's just a regular link expression that's using a behavior of those data types. It's really pretty slick.